Awesome choice. Let's go ahead and dive into going over graph design. For this discussion, we are going to go over 3 topics real briefly. The first is variables and where to find them on a graph, knowing when we should use a bar graph versus a line graph, and then we will conclude with a discussion on careful interpretation of graphs. Starting with variables, no matter what type of graph you are making, your independent variable will always belong on the x-axis. That is our horizontal axis of the graph. And your dependent variable will always belong on the y-axis or vertical axis of your graph. This is just another reason why it is so important to be able to distinguish your independent variable from your dependent variable, so we can present our information in a logical fashion. So applying this to our next check-in number 14, being careful that we're looking at number 14, you set out to answer the research question, does biofertilizer increase plant growth? You develop an experiment and collect the following data. When converting your data into a graph, what would you put on the x-axis and what would you put on the y-axis? All right, now that we have touched on variables in our graph, let's go ahead and learn about when we should use a bar graph versus a line graph. For this segment, I'm going to go ahead and refer you on over to our friends at 24/7 Science, where you can have a more interactive, engaging moment to learn about bars versus line graphs using zombie data. Have fun! Oh, and to find the link to this, you can also just go down in the description and find a link to the video that I'm referring to. When you're done, come on, circle back, and we'll go over some more check-in problems. All right, I hope you found that video as fun as I did. Now let's go ahead and circle back for question number 15. Again, this is check-in number 15. You are given a data table that looks at things an average person would do during the zombie apocalypse. Sound familiar? What type of graph should you use to represent your data? Check-in number 16. Fill in the blanks. Graphs are used to show trends or changes in one variable over time, or over another continuous variable, such as temperature. Whereas graphs are used to compare different groups or categories to each other. Check-in number 17. You set out to answer the research question, do 14-year-olds get more sleep than 18-year-olds? You then collect the following data, shown to the right. What type of graph should you use to represent your data? Check-in number 18. You set out to answer the research question, does biofertilizer increase plant growth? You develop an experiment and collect the following data. What type of graph should you use to represent your data? And now, check-in number 19. Max is researching the relationship between temperature and solubility, which means how well something dissolves in something else. Their alternative hypothesis is, if the temperature of water increases, then more salt can be dissolved in the water. Max develops an experiment and collects the following data. What type of graph should Max use to represent their data? So just to check back in, so far we have covered where variables go on a graph, as well as how to determine whether to use a bar graph or a line graph. Let's go ahead then and conclude our discussion with covering cautious interpretation of figures. If you were asked to interpret this graph, what would you do? Well, first, we could start by looking at our axes, right? So here we can tell that we are looking at the relationship between the number of ice cream cones sold and the number of people with sunburns. And looking at the graph itself, we can see that as one variable increases, the other is increasing too, meaning that the higher the number of ice cream cones that are sold, the higher the number of people we see with sunburns. This is where we need to be careful though. Just because there is a relationship does not mean that they are related. Have you ever heard of the phrase correlation does not equal causation? If not, no worries. But if you have, this is exactly what it means. Just because two variables show a relationship to one another on a graph does not mean that one causes the other. So even though the number of ice cream cones sold increases when the number of people with sunburns increases, that does not mean that ice cream cones are causing people to get sunburns, or vice versa, right? In fact, in this specific example, it's far more likely that the fact that both ice cream sales and the number of sunburns are going up is caused by hot weather, as opposed to being caused by each other. So in short, when evaluating a graph, just be mindful that just because there is a relationship, we cannot be certain that one variable caused the other. All right, well, awesome work today. Let's wrap up with some practice. Check-in number 20. You set out to answer the research question, do 14-year-olds get more sleep than 18-year-olds? You then collect the following data shown to the right. Now turn the data table above into a graph. Be sure to title your graph and label your axes. You set out to answer the research question, does biofertilizer increase plant growth? You develop an experiment and collect the following data. Turn the data table above into a graph. Be sure to title your graph and label your axes. And now finally, check-in question number 22. Interpret this graph. And by the way, this is a real graph put out to us by National Vital Statistics Reports and the U.S. Department of Agriculture. And to help you out with this prompt, I provided some options for you to choose from below, so feel free to select all that apply. And once you're done with Check-in 22, that concludes our discussion on data analysis and interpretation from a graphing standpoint. Awesome work!